let's begin. So, we're going to now solve equations, and when we solve equations, one of the harder things that you would have picked up as you were doing this as well is when you have horizontal translations. So if you have a look at these equations here, I've taught you how to do it when you have a dilation. I've taught you how to do it when it's factor 3, factor 2. It's exactly the same method that you will be doing to solve for when you have left and right. Okay? Because the up and down doesn't matter. It's the left and rights that will change things. Now, with the left and rights, you're doing exactly the same thing you're going to do on how you did dilations. The problem to it is you're going to have to think about the unit circle a bit differently, okay, in terms of where you're starting. And that's the only part that makes it feel new, but in terms of the method, it's still exactly the same. So what I'm going to do is I'm going to do this example. Wait, which I'll do, I'm just looking at which one will give you a nice value so you can see. I'm going to do 3a. Okay, I'm going to do 3a. So there's not only is there a dilation, but there's also a translation. If you can do that, that means you can do the other ones as well individually. Okay, so I'm going to do 3a. You can have a go with 3b unless you feel that you want me to do it again, then I'll do 3b and you can have a go at 3c. Okay, but I'm going to do it over here. I'm just going to leave this here and we're going to now look. I'm going to do it on the board so you can see and compare. And then you have a go with B or C. Okay? So, let's look at this. You've got the equation y equals to 2 sine of 2 times x plus pi on 4 or 3 plus 1. Okay? You want to find the x-intercept. How do you find the x-intercept? What do you have to do first? Make y equal to 0. Okay, that's the first thing you're going to do. So you're going to say, all right, we're going to make y equal to 0. And you got 2 sine, yeah, I'll just do double brackets here. Hopefully that doesn't confuse you. Everything's still the same. Okay? You're still going to try to move everything to the right. You're trying to undo everything so you can solve for x. Okay, it's from negative pi to pi, so it's different now. Starting from negative pi to pi. Yes? Say it again. Like there? Is that what you mean? Yeah. No. It doesn't matter. I'm doing it this way so that you understand it's sine of this entire thing. So what I'm trying to say is, I did the double bracket so that you could see this is the angle. Okay, so that's the angle. That's what I'm doing there. So, because if I don't put in that bracket there, it looks a bit weird. It looks like sine is by itself. It isn't. You see, sine is sining of an angle. Remember, it's always sine of an angle. So this is your angle here. It's 2 bracket x plus pi and 3. That's your angle. Okay? Whereas all the other ones, it was easy previously. You see, if I just move up a bit, see, previously it was 3x only. Previously it was just 2x. Previously it was just, well in this case is again same thing, 3x minus pi and 4. It's actually all together. That's your angle. Right? So, how does it change your problem? How does it change your problem? Nothing new. Exactly the same technique. We're still going to try to move everything across. So what you're going to do here is you're going to say plus 1, minus 1 both sides. Actually, I'll make that equal 0. So minus 1 both sides. You get now negative 1 equals to 2. I'll do it in purple so you guys can see. Negative 1 equals to 2 times sine of 2 times x plus pi on 3, all brackets. Okay, so I'm just moving everything across just the way you normally do. That's a times 2, so divide everything by 2. So I'm going to divide this side by 2, this side by 2. 2's cancel out, and I now have negative half is equal to sine of 2 bracket x plus pi on 3. Have I confused anyone there? I'm just inversing the operations, yeah? So I'm going to write that next line here. I'm going to skip all the steps, and I'm just going to write over here. So we're up to this step. We're now up to negative half is equal to sine of, I'm going to write this in blue so you can see, 2x plus pi on 3. Okay, so that's my angle. 2 times x plus pi on 3, this is my angle, right? What I said to you was, whatever, if it was 3 times the x, if the angle changes, normally it used to be x, it used to be sine of x. Now it's sine of this whole thing. So the first thing you're going to do is you're going to change that domain. Okay, so if it was 2x, you said double domain. If it was 3x, you double or you triple the domain. Well, then now not only are you doubling, but you're also moving the graph. Okay, so how does that change things? This is how it's going to change things. Your domain now currently is x was between negative pi to pi, right? What you're saying here is you're saying whatever x is, plus by pi and 3, and then double that. See? So it says whatever x is, plus by pi and 3. So I'm going to take my steps here. I'm going to say x plus pi and 3 first, because that's the brackets, yeah? That was inside the brackets. So I'm going to do the inside the brackets first, x plus pi and 3. So pi plus pi and 3 gives me now 4 pi and 3. Agreed? And this is negative pi plus pi and 3. That gives me now, am I right there? Yes. Yeah. Okay. So what I've done here is I'm just going to write over here so it's a bit cleaner so you can see. I've just changed my domain from negative pi to pi. And so when I say x plus pi on 3, pi plus pi on 3 is 4 pi on 3. And this is negative 2 pi on 3. So all I did was I just said, you add by pi on 3, you add by pi on 3.
So, hey, sir.
Yep.
What's the difference between x is
Element.
So negative pi, comma pi, and negative 0, comma 2 pi. What's the difference? It all shows the circle.
It is all circle, but in terms of the graphing, it's different. The difference between it is you can either have 0 to 2 pi, or you can have negative pi to pi. So you exclude, you're only drawing that part. So that's the difference between the two. So when you say negative pi to pi, you're restricting the domain just from here. When you say 0 to 2 pi, you restrict the domain from here to here. That's the difference. Yeah.
I'm going to show you that.
And that's what I'm going to show you now. Yeah. Okay. So, here we go. So once we got up to this step, what I was trying to say is, this is the angle. Just like how you always done, you change the domain. Now that was pi plus pi and 3. So if it's got 2, times it by 2. So 2 bracket x plus pi and 3 will give you a new starting point and end point. Okay, so this is now 2 times that gives me 8 pi on 3. And 2 times this is negative 4 pi on 3. Okay? The reason why this is tricky, because in your unit circle, especially the ones that you were doing before, especially with the domain where it was 0 to 2 pi. So remember how, I'm just going to do a tangent here. Remember how the ones you were doing before was 0 to 2 pi? And that was for sine of x. But then when I gave you sine of 3x, what you did was you said 3x is between 0 to 6 pi. True? So what you did here is you just times 2 by 3 and 0 by 3. And the nice thing here, or which you didn't notice, is in a unit circle, you were still starting here. That was 0. And you moved around the circle until you reach 6 pi. True? Well, it's exactly the same thing, except the difference, and this is why it's a bit trickier, instead of starting at 0, and instead of finishing at 6, you are now starting at negative 4 pi and 3, and you're finishing at 8 pi and 3. So you don't always have to start here. It doesn't have to be here. It could be anywhere around the circle. It doesn't matter. Okay, in this case, I've just moved it. I've just moved it to start. This is my starting point. That's my end point. So that means now you have to picture the unit circle, and you say, all right, well, where is negative 2 pi on 3, and where is 4 pi on 3? Okay, so we think about the unit circle. If this is 0, then negative 2 pi on 3 is is just short of negative pi by pi on 3. So it should be in this region. I'm going to color it in black here. This must be pi on 3. This must be negative pi at this point. Right here, right there, which I'm going to color here, this is where negative 2 pi on 3 is. So that distance from here to here is negative 2 pi on 3. Okay, so I'm starting at this point. Instead of starting here, which is what you were used to, and you go around the circle until you get to 6 pi, well now you're starting right there. And you're going to go around the circle until you reach 4 pi on 3. And it just so happens that 4 pi on 3 also finishes here. Okay, how do I know that? Because 4 pi on 3 is exactly one whole with an extra pi on 3. Yeah, 1 pi plus another pi on 3. So that's why I know I'll be moving around the circle, going from here, negative 2 pi on 3, I'm moving around the circle. This now gives me pi with an extra pi on 3, makes it that I finish here at 4 pi on 3. Oh, okay, it's a bit delayed.
Mr. Trey.
Oh, it's negative 4 pi on 3, is it?
Yeah.
Oh, well, did I do it wrong? Negative, oh, because it's 8 pi on 3. It's 8 pi, sorry. I gotta fix the circle again then. All right, let's start it again. So again, draw your unit circle. Oh, you know what? I'm gonna do it over here. Yeah.
So when you go around the circle, do you follow the new domain? Or do you follow the original domain?
New domain. Always the new domain. That tells the end point, start point. I mean start point and end point. Yeah? Alright. Let's do this again. So, same thing. Negative 4 pi on 3 would tell me if this is negative pi, negative 4 pi on 3 has to be a bit further. So it is right here. That must be negative 4 pi on 3. Okay? Because this is negative pi minus an extra third gives you negative 4 on 3. Okay? Because this is negative 3 pi on 3 minus an extra 1. Makes sense. If I'm going anti-clockwise, that's where negative 4 pi on 3 is. Yeah? So I'm starting here. I'm going to put an S for starting. And I'm finishing at 8 pi on 3. I've done that wrong actually. No wonder why. Because I forgot to double it. 2. Alright, there we go. When it comes up. Okay? So the next one is 8 pi on 3. So we've got negative 4 pi on 3. We've got to work out where 8 pi on 3 is. Now 8 pi on 3 is technically short of 3 pi by pi on 3. Because this is the same thing as saying 9 pi on 3, take away pi on 3. But 9 pi on 3 is the same thing as 3 pi. So 3 pi is over here. That's where 3 pi is. Because if you think about it, that's 1, 2, 3. So 3 is sitting here. It's the same point. So they end up being, you start and end at this point. So now you know where you start and end. The question is, what are you looking for? So you're looking for sine, which is the y values, exactly the same way you've been doing. Sine is the y values. When is my y values negative? Negative half. Okay, so if you think about the y values in the unit circle, this is your y-axis. That's negative 1, that's positive 1. So negative half has to be here. Which regions, where around the circle would you have that height? Has to be here. Here, because that's the only time where both y values, at those coordinates, y values are negative halves. So now, this is what I know. And now you go to your exact values just like you normally do, and you say, well, sine of what angle will give you that height? 30 degrees. See, this is, we know that's half. So sine of what gives you half? That's where you go back and do the exact values. And I know that's 30 degrees. That means I know this is also 30 degrees, which is also pi 6. And that means this distance here is pi 6, and the distance from here to here is pi on 6. And you do exactly the same thing. So whatever you've been doing previously, you're doing exactly the same thing. Instead of starting at 0 and finishing at 6 pi, you are now starting at negative 4 pi and 3, and you're working until you get to 8 pi and 3. Okay, so we're going to write our solutions. Let's go. So here we go. I do sine inverse both sides. Sine inverse of negative half is equal to 2x plus pi and 3. I'm going to work out this value, so let's write out our solutions. We've got 2 bracket x plus pi and 3, right? Let's work out our solutions. So our solutions would be, starting at negative 4 pi and 3, I'm going to work my way towards 8 pi and 3. So starting from here, my first point here is negative pi. Negative pi, getting to my first solution, is plus pi on 6. So that makes sense where I say here, my first solution is negative pi plus pi on 6. That's my first solution. Then I keep going around the circle. So if that's negative pi, I'm moving all the way here. That has to be 0. But I reach another solution, and that solution there is short of 0 by pi and 6. Yep.
So you still count the radius from like you wouldn't count. You wouldn't take like pi and 6 plus whatever that
Yeah, you're right. Like these coordinates are still the same. It's still 0, pi, pi and 2, 3 pi and 2. It's just where you're starting the revolution. So you used to start your revolution here, but you can start it here as well. It goes around one revolution, you come back here. And that's important because sometimes you will sort of get close to a second solution, but you don't reach there because you start here. Something like that. That's why it's important to know where you are in the unit circle. Yeah. But in terms of technique, it's still the same. It's still the same. So it's still 0 minus pi and 6. So I got over here, 0 minus pi and 6. And then I keep going because I need to get to 8 pi and 3. And 8 pi and 3, I'm going all the way. And I've now reached pi. That's not 8 pi and 3 yet. Okay, 8 pi and 3 is another, going all the way around to 3 pi. So I've reached here, and I got to go again. So going again, this is now pi, extra pi and 6. So I write down my solution. I'm like, okay, that's now pi, extra pi and 6. And then you go again. You go again from pi, go all the way here, you get now to 2 pi.
2 pi minus pi.
Yes. So now you're short of 2 pi by pi and 6. And then as you can see from 2 pi, this is when you finish at 8 pi and 3. Okay, so I've done my revolution. I've done technically 1.5. That's what I've done. I've done a 1.5 revolution, and I've got these solutions here. Okay, but remember this is all extended. You've changed the domain just to cater for it. So at the end of all this, you're going to have to move it all the way back. Okay, so let's see what we're going to do. We're going to simplify this first. That gives me negative 5 pi and 6. That gives me negative pi and 6. That's what's 7 pi and 6. 12, 11 pi and 6. Okay, now to undo everything, you have to take your steps back. You doubled it at the end, so you now got to halve it. You plus pi and 3 to start off with, then you minus pi and 3. Okay, so that's what we're doing here. Divide everything by 2 to undo that doubling. So divide that by 2, divide by 2, divide by 2, divide by 2. You now have negative 5 pi on 12, negative pi on 12, 7 pi on 12, 11 pi on 12, and finally you had plus pi and 3. So undoing that problem, minus pi and 3, minus pi and 3, minus pi and 3, minus pi and 3, minus pi and 3. Okay? And we know that we can subtract fractions if the denominator is the same. So technically 11 minus 4. So I'm just going to write my answers over here. Negative 5 minus 4 gives me now negative 9 pi on 12. This is negative 1, take away another 4. So that's negative 5 pi on 12. This one's 7, take away 4, which is 3 pi on 12. And then my last one, 11 take away 4 is 7 pi
on 12.
If you're having troubles with fractions, just take your time. So, for example, negative 5 pi on 12, take away pi on 3. What I did was I just said, times this by 4, times that by 4. So that makes it 12. Negative 5, take away 4, negative 9 pi on 12. So I just took negative 5, take away 4, take away 4, take away 4.
If I'm on that, it's going to be simplified.
Okay, and that's the technique. So it's exactly the same way you've been doing. The only extra part is you now have two things to do. That's why it's tricky. And you're starting at a different point. That's the only reason why. But otherwise, what I've been teaching, it's the same theory, same everything. And that's your goal. Okay, this is the hardest part to sort of get across to students to solve. But that's what I want you to be able to do. Yeah?
Someone says can simplify it.
Yeah.
9 over 0, 0 over 0, something like that.
What's that? 3, 4, yeah?
Alright.
Alright. Help? Alright. Have a go with B and C. Please check your answer. This is from your textbook. It's 14J. Try the question 3, the one with the translations. See if you can get the x-intercepts. If you're getting the x-intercepts, it means you've learnt this, and that's good, because it means sketching is so much easier now. This is the hardest part. Once you've got the hardest part, everything else is easy. Okay? I'm going to go over and help, and then I'll come back to check up on all of you.